Greetings and welcome to my new calculus channel once again. My name is John Gabriel and this is another one of those short Pithy videos in the series that I started some time ago. And so what I'm going to do in these short videos, as you know, is just address topics that students of mathematics or those who wish to learn mathematics encounter a lot of difficulty in understanding. So this one is about the remainder theorem. Now, mainstream sources state the theorem as follows. They say that if f of x is a polynomial, then f of r is f of x divided by x minus r. Okay, so in particular, we say that f(x minus r) is a factor of f if f of r is equal to 0. So now this, to begin, all this will seem very confusing. Okay, so what exactly is happening in the process of division or long division, and what does division mean? Okay, so division is a measure whereby a given dividend is measured by a given divisor. Now, the divisor is called a factor if there is no remainder. That is, if f of r is equal to 0, right? So, since the divisor is used to measure the dividend, the simplest way is to use x as a divisor. And in this case, all the terms in x are measured exactly, leaving a remainder if and only if the polynomial contains a term or terms that are constant or do not have x as a factor. So in this example here, which I'll show you, 3x cubed plus 4x squared minus x has no remainder, okay, when divided by x. That means x measures every term in the given polynomial exactly. It measures 3x cubed as 3x squared, 4x squared as 4x, and minus x as minus 1. So if we add a constant to the example, then we can simply ignore all the terms in x, and the constant would be the remainder, as you see over here, right? So setting x is equal to 0 here has the same effect as just ignoring the terms in x. Now, notice that if you consider 0 to be a number, then a factor of this polynomial is x minus 0. And from this, it should be easy to see that x minus r will be a factor if x is equal to r with no remainder. So unlike dividing a polynomial by x minus r, you cannot split up the partial divisors if you use x minus 0, because division by 0 is meaningless nonsense. And I'll show you an example toward the end of two examples of partial divisors. So to understand this paragraph here, you need to watch this short video and also this short video in which I explain how division is extended to polynomial long division. And here I give you an example. I'll show you that if you divide this polynomial by this divisor, then the remainder is 4r squared plus 3r cubed minus r, and as can be seen, the remainder will only contain terms in r. So therefore, if we wanted x plus r to be a factor, we would simply change this polynomial to this polynomial. Okay, so for example, if r is equal to minus 1, then the polynomial would be that, or this if r is equal to 1. And you can check that by stopping the video and doing it in your own time. So be sure to study my free article on how we got arithmetic. It's very important, and division is simply an application of repeated difference measures. So for example, to measure 9 using 2, we see that 2 measures 9 4 times, and then if we need, and that we need half of 2, that is 1 to complete the measure. So 1 is considered to be a remainder in this case, meaning the measure is incomplete unless we further divide the divisor 2 into equal parts, from which we can complete the measure. So measure by definition is complete, not partial or approximate. Now division, whether short, long, or polynomial, is based on Euclid's algorithm. So while Euclid's algorithm is systematic, division can be formed in innumerably many ways, or as they say in the mainstream vernacular, infinitely many. I hate that expression. So we can choose whatever partial divisors, partial quotients, or dividends we like and still arrive at the same result. So in the following slide, I'm going to show you how to do this in two ways, but there are infinitely many ways. So here are two ways to do it. So I start off with the partial quotient of 400 multiplied by all the partial divisors, and I arrive at partial quotients here, and I subtract them, and I see that I over measured, okay, because 400 is already greater than 207. Not that I know that, but I mean, we would basically get to the result by saying, okay, well, let's just see if we can find a quotient that will take us up to 4,000. And one such quotient is maybe 100 or 150 or 175 even. And in each case, if you look at these examples, you will get to the same result. So that's basically it. I just wanted to show you that the remainder theorem isn't hard at all. It's really just nothing else except division, and it extends to polynomial division. So if you're not already a subscriber, become a subscriber, spread the news of my channel, and I'll place a link in the details section to which you can donate currency or credits. I'm John Gabriel. This is New Calculus Channel. Till next time, goodbye.